I am going to start trigonometric equations. In trigonometric equations, I am going to discuss past year IIT JEE Advanced Level questions. Let us go to solve the question here. The number of distinct solutions of the equation 5 by 4 cos square 2x plus cos power 4x plus sin power 4x plus cos power 6x plus sin power 6x is equal to 2 in closed interval 0 comma 2 pi is. So this is clearly integer answer type question. Now let us go to solve the question. We'll see the solution here. So first let me note down the given equation here. So what is given equation here? 5 by 4 into cos square 2x plus cos power 4x plus sin power 4x plus cos power 6x plus sin power 6x minus 2 is equal to 0 I am going to write here. Now what I am going to do here, so it is purely computative approach. In place of cos power 4x plus sin power 4x, what I am going to write? 1 minus 2 sin square x into cos square x. Again in place of cos power 6x plus sin power 6x, I am going to introduce 1 minus 3 sin square x into cos square x. Now here 1 plus 1 2, so 2 get cancelled here. That means the numerical values I have cancelled. Now adding like terms, minus 2 minus 3, so that means it is going to be minus 5 sin square x into cos square x. Next, see the next arrangement here, multiplying and dividing by 4. Multiplying and dividing by 4. In place of 4 sin square x into cos square x, what I can write here? Sin square 2x. So finally, from these two terms, 5 by 4 common, cos square 2x minus sin square 2x is nothing but cos 4x. So we have 0 on the right side. So this implies numerical value 5 by 4 cannot be equal to 0. Then cos 4x will be equal to 0. So this is of the form cos theta is equal to 0. We know that cos theta is equal to 0 for all odd multiples of pi by 2. That means in place of theta we have 4x. 4x is equal to, we can write 2n plus 1 into pi by 2. So this implies from here x value I want, x is equal to 2n plus 1 into pi by 8, where n belongs to integer set, where n belongs to capital Z. So x value I have got 2n plus 1 into pi by 2, comma n belongs to Z. Here different solutions we have been asked to find. Next, in place of n, I would like to give different values, but I have to concentrate on the interval also here. So first, in place of n, I am putting n is equal to 0 here. So then x is equal to pi by 8. So pi by 8 is nothing but 22.5 degree. Next, in place of n, if I write n is equal to 1, it is going to be 3 pi by 8. So that is equal to 3 into 22.5 degree is nothing but 67.5 degree. So that means we are getting odd multiples of pi by 8. That means we are getting odd multiples of pi by 8 here. Now I am not going to find all the values which are lying between 0 and 2 pi. I would like to apply some logic here. See here. I have got two values between 0 and 90 degree. That means up to 90 degree, I have got two values. That means what is the given interval, you know? So given interval is 0 to 2 pi. This is the given interval, 0 to 2 pi. I have divided into 4 equal parts here, 4 equal parts. So first one, 0 to pi by 2. Second one, 0 to pi. Third one, pi to 3 pi by 2. And fourth one, 3 pi by 2, 2 pi. Like that I have divided. So that means 0 to pi by 2, I have got two different solutions here. Next, how many subintervals are there? Totally 4. So that means, so 2 4s are is nothing but 8. So total number of distinct solutions I have got 8. So clearly it is a integer answer type question. So answer for this question is 8. I hope that you have understood this question very clearly. Now let us go to discuss another question. Let capital S is equal to set of x belongs to open interval minus pi comma pi such that x not equal to 0 comma plus or minus pi by 2. The sum of all distinct solutions of the equation root 3 into secant x2 plus cosecant x2 plus 2 times tan x minus cot x is equal to 0 in the set capital S is equal to. So these are the 4 options. We'll see the solution for this question. So here set is given here. So this is the set capital S. So in this set x belongs to open interval minus pi comma pi. That means x is lying between minus pi comma pi. Here condition is given x not equal to 0, x not equal to pi by 2, x not equal to minus pi by 2. This is the given equation. So we have to solve this equation to find the all distinct solutions, especially all the solutions which are lying in this interval. Now let us go to take the given equation. So first, here given equation, root 3 into secant x. I would like to take the support of trigonometric identities. In place of secant x, 1 upon cos x, so I would like to introduce. Plus, second term is cosecant x. I am going to write in place of cosecant x 1 by sin x plus 2 times tan x can be written as sin x by cos x minus cot x can be written as cos x by sin x equal to 0. So this is the given equation. Now, so what is LCM here? Cos x into sin x. Then this implies root 3 is multiplied by, here root 3 should be multiplied by sin x. Next, here 1 should be multiplied by, here 1 should be multiplied with cos plus 2 times cross multiplication sin x into sin x, sin square x minus cos x into cos x, cos square x. So as we have the 0, on the right side, need not to write the denominator on the left hand side. Next, I would like to divide the whole equation by 2. Here dividing by 2. So this is root 3 by 2 into sin x. When I divide by 2, it is going to be 1 by 2 into cos x. Next, when I divide by 2, 2 get cancelled. So that is equal to, here I would like to send last 2 terms to the right hand side. They are going to become cos square x minus sin square x. In place of cos square x minus sin square x, I can introduce cos 2x directly. Now I have seen cos 2x on the right side. I am going to convert the left side part also in terms of cos. So simple here. In place of 1 by 2, I may introduce cos 60 degree. that is nothing but cos pi by 3. In place of root 3 by 2, I can write sin 60 degree, that means sin pi by 3. Now this is of the form cos A cos B plus sin A sin B. So how we can write here? Very simple here. This implies left side part is going to become cos x minus pi by 3. Right side we have cos 2x. Now this is of the form cos theta is equal to cos alpha. So I have got this form. Cos theta is equal to cos alpha. Cos theta is equal to cos alpha if and only if theta is equal to 2n pi plus or minus alpha comma n belongs to capital Z. Next, now I am going to apply this formula here. Here 2x is equal to 2n pi plus or minus x minus pi by 3. That means 2x value I have taken like a theta, x minus pi by 3 I have taken like alpha. So theta is equal to 2n pi plus or minus alpha. So from here 2x is equal to 2n pi. First time plus I would like to take x minus pi by 3. Next again 2x is equal to 2n pi. Next time minus I would like to consider. When I consider minus sign, I want to open the brackets directly by simply multiplying with the minus. I am getting minus x plus pi by 3. Next, we need x value. If I bring this x to the left hand side, it becomes negative. That means 2x minus x, x. So right side we will be having 2n pi minus pi by 3. Next, similarly, if I bring this x, if I bring this negative x towards the left side, it is going to be positive. Then 3x is equal to right side part. But I need only x value. Dividing by 3 on both the sides. That means x is equal to 2n pi by 3 plus pi by 9. Now, first of all, we have to find all distinct solutions here. But we require their sum. So here interval is given. What is the interval here? X belongs to minus pi comma pi. So in this interval only we need the solutions here. For x, I have got two general solutions here. One is 2n pi minus pi by 3. Second one 2n pi by 3 plus pi by 9. In place of n, if I give 0, here x value is equal to, here what is x value now? X is equal to minus pi by 3. Here minus pi by 3 is clearly lying in this interval. Next, I want to give one more value for n. Put n is equal to 1. So here x value is going to be 2 pi minus pi by 3. That is nothing but 5 pi by 3. So 5 pi by 3 is not belonging to this interval. That means we have to consider only n is equal to 0. So going beyond n is equal to 0, wasting of time. If I give negative values for n, I am going to get the values which are not lying in this interval. So giving negative values for n is wasting of time. Now we will focus on the second general solution here. Now first put n is equal to 0 here. Then x value pi by 9. So pi by 9 is nothing but 20 degree. So 20 degree is clearly lying in this interval. Next, when n is equal to 1, it becomes, then x becomes 2 pi by 3 plus pi by 9. So that is nothing but 7 pi by 9. So that means 120 degree plus 20, 140 degree. So 140 degree is clearly lying in this interval. So this value is acceptable here. Next, if I give n is equal to 2, if I write in place of n 2, then it is going to become 240 plus 20, that means 260. 260 is not lying in this interval. Now let me check for negative values. Now in place of n, I would like to give negative values here. That means a negative number I am going to substitute. Put n is equal to minus 1. It is going to be, then x is equal to minus 2 pi by 3 plus pi by 9. So this is nothing but minus 5 pi by 9. So minus 5 pi by 9 is equal to minus 100 degree. So minus 100 degree is clearly lying in this interval, acceptable. So by putting n is equal to minus 2, it is wasting of time. Next, what is required here? What we have to find? We have to find sum of all the distinct solutions here. So here, how many solutions I have got here? First one minus pi by 3. Second one minus 5 pi by 9, and next one plus pi by 9, and next one plus 7 pi by 9, because here sum means I have to add all the solutions here. So finally I have got 4 solutions. I want their sum. LCM 9, then it is multiplied by 3 minus 3 pi it is. It is multiplied by 1 minus 5 pi it is. It is multiplied by 1 pi. It is multiplied by 1, then it is 7 pi. So that means minus 3 pi minus 5 pi minus 8 pi and plus 8 pi. So that means 0 it is. 0 upon 9, 0. So finally, sum of all the distinct solutions of this equation is 0. So 0 is clearly available in option C. So it's a very good question, but time consuming. There is no another alternate way. Now let us go to discuss another question. Let alpha and beta be non-zero real numbers such that 2 times cos beta minus cos alpha plus cos alpha into cos beta is equal to 1. Then which of the following is oblique or true? So these are the 4 options. It is clearly more than one correct answer type question. Right. We'll see the solution for this question. Here, alpha and beta are 2 non-zero real numbers such that 2 times cos beta minus cos alpha is equal to, I can write 1 minus cos alpha into cos beta. That means I have sent this term towards the right side directly. If you are going to observe the options clearly, each and every option is in terms of tan alpha by 2 and tan beta by 2. That means in place of tan alpha by 2, that means in place of tan alpha by 2, I want to introduce x. In place of tan beta by 2, I would like to introduce y. Then first option is going to become root 3x minus y is equal to 0. Second option is going to become x minus root 3y is equal to 0. Third option will be x plus root 3 y is equal to 0. And last but not the least, fourth option will be root 3x plus y is equal to 0. So for my convenience, I have changed the options like that. Now come to the question here. This implies here 2 times. So in place of cos beta, what I can write here, cos beta is nothing but 1 minus tan square beta by 2 by 1 plus tan square beta by 2. So in place of cos beta, directly I can write 1 minus y square by 1 plus y square. Here y is nothing but tan beta by 2 minus, in place of cos alpha, 1 minus x square by 1 plus x square. Here x is nothing but tan alpha by 2. Left side part has been completed. Now we'll see the right side part here. 1 minus cos alpha cos beta. First cos alpha value. Here cos alpha value 1 minus x square by 1 plus x square into cos beta value 1 minus y square by 1 plus y square. We have to simplify this one. So that means some calculation part is involving. It differs person to person. So one must take the risk while doing the calculation part, right? This implies, first, it is going to be LCM for left hand side and it is going to be LCM for right hand side. So both the LCMs get cancelled. That means I need not to write. So 2 times, first multiply with 1. I'm doing the cross multiplication here. First multiply with 1. 1 plus x square. Next multiply with minus y square. Minus y square minus x square y square. Next we have minus sign here. Next we have to multiply these 2 terms. First multiply with 1. 1 minus x square. We have minus sign here. Multiply with minus 1. It becomes plus x square. Next multiply with y square. Y square minus x square y square. But we have minus sign na, multiply with minus y square plus x square y square. So left side part has been completed successfully. Simplify the right side part here. So already we have taken the LCM, which is 1 plus x square into 1 plus y square. First multiply these 2 terms, cross multiplication with 1. Cross multiplication with 1. So first when I multiply these 2 terms, first multiply with 1 plus y square. Next multiply with x square plus x square y square. Cross multiplication with 1 means we get the same result here. Next we have minus sign here. Now we have to multiply these 2 terms. After that multiply with the minus outside. When I multiply with 1, I am getting 1 minus y square. If I multiply with minus, it becomes minus 1 plus y square. Next multiply with minus x square. Instead of that, already minus is there, na? Minus into minus plus, directly multiply with plus x square. So x square minus x square y square. So this is the simplification part on the right side. Here x square y square, here x square y square get cancelled. Next here plus 1 minus 1 get cancelled. Now we'll see the right side part here. Here plus 1 minus 1 get cancelled. Here this positive term and this negative term get cancelled. Now what is left we will see here. So outside 2 is there. Let it be written as it is. Here x square plus x square, 2x square, minus y square minus 2y square. This is the left side part, that is equal to, we'll see what is left on the right side part. Here x square plus x square, 2x square. Next y square plus y square, 2y square. I'll take 2 common here. Now both the sides of 2 get cancelled here. So this implies, if I bring x square towards the left side, 2x square minus x square is nothing but x square. That is equal to, I would like to send this minus 2y square towards the right side. It becomes so positive. Already y square is there. Plus 2y square. Y square plus 2y square. 3y square. So finally x square is equal to 3y square I have got. Now, so this is of the form a square is equal to b square. How can we write? A plus b, this is of the form a square is equal to b square. This is of the form a square is equal to b square. How can we write? a plus b into a minus b equal to 0. So this is of the form a square is equal to b square. How can we write a plus b into a minus b is equal to 0? Right. So finally, when I equate first factor with 0, second factor with 0, I am going to get the answers. Now first one, x plus root 3 y is equal to 0. X plus root 3 y is equal to 0. It is clearly available in option C. X minus root 3 y is equal to 0. It is clearly available in option B. So I hope that you have understood this question very well. Now let us go to discuss another question. The set of values of theta satisfying the inequation 2 sin square theta minus 5 sin theta plus 2 greater than 0, where 0 less than theta less than 2 pi is. These are the 4 options. We will see the solution for this question. So first consider the given inequation here. 2 sin square theta minus 5 sin theta plus 2 greater than 0. Here the middle term minus 5 sin theta. Here the middle term minus 5 sin theta can be broken into 2 parts. Minus 4 sin theta minus sin theta. Now from these two terms, 2 sin theta common. If I take 2 sin theta common from the first term, what is left? Only sin theta minus. If I take 2 sin theta common from the second term, what is left? Only 2. Next, from the last two terms, I am going to take minus 1 common in order to get the same factor here. So minus 1 I am going to take the common. Minus 1 I have taken the common here. Sin theta minus 2. There is no change in the inequality sign here. Greater than 0. Now 2 sin theta minus 1 sin theta minus 2. So these are the two factors for this inequality. Now it is clearly of the form x minus alpha into x minus beta greater than 0. That means how can we write x less than alpha or x greater than beta? Here condition is alpha less than beta. Beta is the greatest here. So that means sin theta less than 1 by 2 or sin theta greater than 2. So according to this notation I have written like that. Already 2 sin square theta minus 5 sin theta plus 2 greater than 0 inequality I have solved. One value I have got sin theta less than 1 by 2. Another value I have got sin theta greater than 2. Therefore sin theta greater than 2, which is not possible. So that means you can ignore this case. Now sin theta less than 1 by 2 only we have. Here we have to find the value of theta for which sin theta less than 1 by 2 in this interval. So I would like to recommend the best method for this graphical method. Now let us go to draw the graph here. So consider coordinate axis here, OX and OY. So first let us go to draw the graph for sin theta. What is the interval given here? Open interval 0, 2 pi. So that means here 0 I have taken. This point would be pi. This point would be 2 pi. Next, What is the maximum value of sine theta? Plus 1. So between 0 and 1, there exists one midpoint which is 1 by 2. Now I am going to draw y is equal to 1 by 2 line. Y is equal to 1 by 2 which is parallel to x-axis and at a distance of 1 by 2 units from the origin. So that means this is the line y is equal to 1 by 2. Now y is equal to 1 by 2 and sine theta curve, they both are intersecting at only 2 points in the given interval. First point of intersection I have got pi by 6. Next, second intersection point would be 5 pi by 6. Now, we are solving for sine theta less than 1. Now I am going to consider the graph which is lying below the line y is equal to 1 by 2. The part which is lying above the line y is equal to 1 by 2 I have eliminated. So therefore, here theta belongs to open interval 0 comma pi by 6. You can see clearly in this interval sine theta less than 1 by 2 union open interval 5 pi by 6 comma 2 pi. In this interval also you can see clearly sine theta less than 1 by 2. So that means in this interval the graph of sine theta is lying below the line y is equal to 1 by 2. Now look at the options here. So very simple here, very simple. Here we have got sine theta less than 1 by 2. So less than means we have to begin with open interval. So in option B and option C, we have closed intervals. We can eliminate. Now for the confirmation we have drawn the graph. So that means our answer is available in option A. Here nota means none of the above. We can cross out the last option which is nota. So I hope that you have understood this question very clearly.